In this lecture, we're going to talk about how derivatives affect the shape of a graph. We're going to start with a result, which we've almost been using kind of implicitly for a while, but let's just make it concrete, that, we'll call this a theorem. So f is increasing on the interval, say from a to b, if and only if f prime is positive on that interval. And similarly, f is decreasing on this interval if and only if f prime is negative. Well, I'm not going to go through the proof in this lecture. Let me just say that it uses the mean value theorem. Let's just jump right to looking at an example of how to use this. Okay, so let's take an example. Let's determine where the function f of x is equal to x cubed minus 9x squared plus 24x is increasing and decreasing. So the idea is that if you want to know where f is increasing, you want to know where f prime is positive, and if you want to know where it's decreasing, you want to know where f prime is negative. Now in this case, f prime is 3x squared minus 18x plus 24. And to know where it's positive and negative, it's going to help to find out where it's 0. And furthermore, to do that, we want to factor f prime as much as we can. So there's a factor of 3 in all of those terms. And if we pull that out, you get x squared minus 6x plus 8. And then if you're lucky, then that factors into integers. So in this case, you're going to get x minus 2 times x minus 4. So that means that f prime is 0 when x equals 2 and when x equals 4. And so what I'm going to do is draw a number line here where we have at x equals 2 and x equals 4. Those are the two places where the derivative was 0. And since the derivative is a continuous function, it's just this polynomial here, then the only way that that polynomial can change from being positive to negative is if it goes through 0. And so what that means is that on each of these three ranges, to the left of 2 and between 2 and 4 and to the right of 4, that within those ranges, the derivative of f prime is consistent. It is either always positive or always negative. So how do we know which it is? Well, if I look at x values that are, say, less than 2, I mean, you can either do this with a concrete value, or you can try to look at it more holistically. So, for example, I could take a value like 0, which is less than 2, and say, well, f prime of 0 ends up being 24, just plugging it back up into this thing right here. And so I got a positive value. And so the idea is I should get a positive no matter what number less than 2 that I plug in. And why is that the case? Well, it's basically because if I take f prime of something less than 2, you're going to take 3 times x minus 2 times x minus 4. And if x is less than 2, then I'll have a positive times a negative, so you get a positive overall. Right, some people will kind of write that out. They'll have a positive times a negative. So that gives you that positive. In between 2 and 4, so if you take something like f prime of 3, well, again, you sort of don't have to care so much about what the exact output is. All I really care about is whether it's positive or negative. So I'm going to have 3, which is positive, times 3 minus 2, which is positive, times 3 minus 4, which is negative. So I get a negative. And then finally, I have one more range, which is things that are bigger than 4. You could pick 5, or you could pick 100 for all that it matters. And you get 3 times x minus 2 times x minus 4. All three of those factors were positive, so you get a positive output. So the conclusion then is this, that f is increasing from negative infinity up to 2, and from 4 all the way to infinity. And then f is decreasing on the interval from 2 to 4. Okay, so this is how a typical example works. If you want to find where a function is increasing and decreasing, what you want to do is find the critical points, and then in between each pair of critical points, determine whether the derivative is positive or negative, and that will tell you where f is increasing and decreasing.